Alrighty, so in this fourth video I will be showing off the Visualizer and the MathTools, and then also within the Visualizer the colors, which is pretty simple. Let's go to the Visualizer. So obviously the Visualizer has very much improved since the last time, since last semester really. I've improved Visualize All, we have Show, B-Sphere, AABB, OBBs, and then I have Submit, AABBs, OBBs, and B-Spheres. I have a Show Collision Volume, and I also have a Terminate, which is very much called. I have privately render B-Spheres, AABBs, and OBBs. So first, I guess I'll just show off. Let's show this. So I have this Visualize All function, which goes through each collection, command collections, depending on what collision volume is being, ran through. So it'll first run through the B-spheres, goes through the B-spheres, executes everything within the B-sphere list, and then we'll push back those commands into a recycled B-sphere collection, and then it'll clear everything in the regular command collection. Same goes with AABBs, same goes with OBBs, or OBBs. So for these things actually to be pushed back, they would have to go through the submit ABBB or AABB, OBB, B-sphere, which are called from the show B-sphere, show ABB. So let's just show these really fast. So the show B-sphere, I showed these off 2 videos ago within the collisions for the different types of volumes. But basically the show B-sphere will submit a B-sphere, same with the AABB will submit an ABB, and a OBB will submit a OBB. So within the submit, we'll show the AABB because all of them basically do the same thing. Submit ABB will see if the recycled collection is empty, and if it is, it'll push back a new AABB command. Otherwise, it'll just add a recycled. It'll set parameters from the recycled collection from the front. It'll push an instance of the recycled collection, and then it'll just pop the front of it. This is the same thing that happens for the OBB collection and the B-sphere collection. I'm quite tired. So then, these privately render functions are called from the commands, but I'll get to that in a second. Obviously, terminate is called everything that should be called and destructor wise is in the game CPP, and it is at the bottom. So obviously, I have all of the managers, and then I have the audio, the time manager, the scene manager, the visualizer. So everything is there, and it is getting called. So yes, now I will talk about, and then if you want to see, here's all the lists for the command collections and then their recycled collections respectively. Now I will show you the visualizer commands. Pretty much like the same thing, just like the broker, just these are visualizer commands now. They have a base class, they have a set parameters, and an execute that they override. I'll show you the OBB. All of them, they do the same thing, minus obviously the execute in these. For the OBB, will call the privately rendered OBB, as with the AABB one, will do the privately render AABB, and then the bsphere, pretty simple, honestly. Going back to the visualizer, visualizers, the privately render will actually like set the color of the wireframe, set the world, and then it'll actually render the wireframe to the camera. So then obviously you can actually see the wireframe. So that's all these three right here. So now we will go to, I guess, the colors, which is simple, I guess. Tools and color, they're all static functions, so they can easily be called. I have black, white, light gray, dark gray, red, blue, and orange, because you can see those the easiest. And then I could show you the math tools. So the math tools has the intersects, the 6 different intersects from bsphere to bsphere, AABB to AABB, OBB to OBB, AABB to bsphere, AABB to OBB, bsphere to OBB, and then I have a special intersection with a min-max points for a bsphere, but that is for terrain, which I will get to in the next video. And then I have intersect with 2 regular, generic collidables. And then I have, obviously I showed you from before, but I put the compute bsphere, AABB, and OBB functions within the math tools as well. So I guess I could show you those really fast. So, intersect bsphere with bsphere, it's just computing the distance between the min distances of the 2 bspheres. Intersecting AABBs, just trying to tell which max and min of X, Y, Z is bigger or smaller than each other. Intersecting between 2 OBBs, basically creating the SAT test, and then looping through each of those SAT tests to determine a length projection. And then obviously if the distance is greater than or equal to the length, the length projections added together, it returns false, else returns true. So we then have the intersect with an AABB and a bsphere. It's just going through and looking to see if the centers of the bsphere are less than the min or maxes of the X, Y, Z axes are less than or greater than, and then has a squared difference which does power. So then AABB with OBB has another SAT test. Actually, I think that's the same thing from before. I don't know. Oh wait, no, it's not. This is AABB and OBB. SAT tests, and then just basically computing the length projections again. bsphere with OBB, pretty much just making sure to get the world, and it gets the inverse of the matrix. It then inverses matrix, it clamps X, Y, Z, and then computes if the point is within the bsphere. And then finally, this is